Okay, so here is the third part of the What's in a Medicine vodcast series. Last time we looked at carboxylic acids and phenols, and today we're going to have a quick look about esters and how to make an ester. Now, this lesson will be the second part of your practical in class because you'll be continuing with the test that you were doing with the phenols and carboxylic acids, and you'll actually be looking at making an ester as well briefly. Now, we are later in this course going to look at esters again, so we will go over them in a bit more detail. This is kind of just an introduction and just getting it so that you've got a taste for it and you understand kind of what an ester is, so it's not just doesn't just come out of nowhere when we look at it in more detail. So, not going to be as long as the other ones. It's a bit more brief. There's just three questions really. So, what's the general formula for an ester? What are the ways of making an ester? And what are the differences between a drying agent and a dehydrating agent? Now, that one's not necessarily to do with esters itself, but it is something that we do need to cover. So, I thought that we'd cover it in this one since there's not that much else that needs doing here. So, first of all, really, is just to look at the ester functional group and what makes a compound an ester. And the main thing, really, that you need to look out for is this C double bond O, so this carbonyl, adjacent to an ether link. Okay, so adjacent to a carbon bonded to an oxygen bonded to another carbon, essentially. So you've got two R groups. They could be the same, they could be different, but this is what you're looking for: this C double bond O attached to an oxygen, which is then attached to something else. So an example, okay, over here, it's this that you're looking for. Yeah, that's the part of the molecule that you're trying to identify. If you see that, then you can go, right, so this is an ester. Okay, it's got this carbonyl and then it's got this ether link here with this oxygen. So that's what you're looking out for when you're looking for an ester. Okay, so we're going to have a look at the two ways to make an ester. And the first way, the simpler way, is making an ester from an alcohol. So it could be methanol, ethanol, etc. And the way that it's done is you react your alcohol with a carboxylic acid. Again, that could be anything, could be methanoic acid, propanoic acid, butanoic acid. And it's done under reflux with an acid catalyst. Sounds a bit weird using a carboxylic acid with an acid catalyst, but what I mean by an acid catalyst is something such as concentrated sulfuric acid. Okay, so a strong acid. So it's done under reflux, acid catalyst with an alcohol and a carboxylic acid, and you just stick them together under reflux and just heat them. Okay, we're going to look at this reaction in more detail later in the course because it's not just as straightforward as that. Okay, because it is actually a reversible reaction, so it's not just that that and done. But we don't need to look at it in too much detail right now. The main thing is really that you just need an alcohol, carboxylic acid, reflux, acid catalyst. What you make is your ester over here. So you can see that it's an ester because we've got our ether link, yeah, C bonded to an oxygen bonded to another C, with this carbonyl. Okay, so that's our ester, and we form water here. Now, this reaction is actually called esterification. Okay, so we're making an ester, it's called esterification, but it's also a condensation reaction. Yeah, so it's, we're forming water here, so it's condensation, but it doesn't have to be water. So in this case, with alcohol and a carboxylic acid, we do form water. But the other case that we're going to look at, we don't form water, but it is still a small molecule. So we can just say that esterification produces an ester and a small molecule. In this case, it's water. Okay, so that's basically it. Okay, that's as much detail as we need for now. So the other way is making our ester from a phenol, right? So the reason that it's different, and it's not the same reagents, is because the OH in our phenol is less reactive. Okay, and that's to do with the delocalization of the electrons, and the fact that it actually extends over to this O over here, and the delocalization causes stability of this structure. So breaking this structure is less favorable. So a phenol is slightly less reactive, which means that we need a different reagent. In this case, it's an acyl chloride, which looks a bit like a carboxylic acid in the sense that you've got an R group with a carbonyl, and then you've got this this extra group here, which instead of an OH is a chlorine. But you can kind of picture it as being a carboxylic acid in the sense that the chlorine and the hydrogen, so this chlorine and the hydrogen from the phenol, will actually leave, forming our HCl, which is our small molecule, and we'll get a new bond forming between this oxygen and this carbon, which is our ether link. So just like I said, we've got a bond between this oxygen over here and this carbon, that's our ether link, and we've got our ester. Okay, so we've formed our ester, and we'd also get HCl formed as well, which is our small molecule. Now this reaction will take place at room temperature, but it has to be done in the absence of water. As we'll come into later, again, like I said, when we look at esters in more detail, since it's reversible, adding water will actually force it to go back the other way, okay, to hydrolyze. Since condensation is the formation of water, if we add that water again, it's going to hydrolyze and it's going to break them up. So we need to do this reaction in the absence of water. Okay, so just a bit of practice then. We have our phenol here, okay, methyl phenol, and we have our acyl chloride, okay. And what I'd like you to do is work out what the products would be. So what is the ester that would be formed from this phenol and this acyl chloride? What would you form? Okay, and just the same for this down here. So we've got an alcohol here and a carboxylic acid. What product would be formed? Okay, so have a think. Whereabouts are the bonds going to be formed? What are the things that are being lost? What are the products that would be formed? So I'll give you a couple of, let you pause here, a couple of minutes just to go through this, and then we will discuss it. Okay, so hopefully you would have realized that the parts of the molecules that are actually going to be leaving, in a sense, the small molecule that's going to be lost, for this case is the H here and the Cl here, so we're going to get HCl lost, which means that a new bond is going to be formed between this oxygen and this carbon. Okay, so we're going to get a bond between this oxygen and this carbon, and that will be our ether link that we're forming. Okay, so this is an esterification reaction, and it will be between this oxygen and this carbon, which means that you would have had to flip this molecule, just reflect it and flip it horizontally. So you'd see that this carbon was then bonded to this oxygen. And similarly over here, hopefully you would have noticed that the hydrogen and the OH would be lost as water, which means a new bond would be formed between this oxygen and this carbon. Okay, again, you just have to flip this molecule, just flip it around so that you've got this methyl group pointing away, so that you can make a nice bond there. I'll just show you that on the whiteboard so you can see it in a bit more detail and see what I mean by flipping it around. Okay, so we'll start with the first one. We have our CH3, which is bonded to our benzene. We've then got our ether link, our C double bond O, and the rest of the chain there. So here's our ester, okay, and there we have the other parts that made up that molecule. And of course, we also have HCl, which is our small molecule that's been lost in this case. And for the second one, we've got our ether link here, our carbonyl part. So there's our ester attached to our CH3. Okay, and we'll also in this case get water as our small molecule. Okay, so hopefully that was clear. We're just going to have a quick discussion about a drying agent and a dehydrating agent, and mainly just because it's good to understand the difference between these two things, since they sound kind of similar. Now, a drying agent is basically something that just removes any excess water. It kind of mops up any water in a sample. It's basically similar to just drying something in an oven. Okay, if you put a solid sample, you put it in an oven, on a low temperature, and you will dry out. You will evaporate the water, and you'll dry your sample. Okay, you'll actually get rid of any excess water. The benefit of using a dehydrating agent, a drying agent such as calcium chloride, something like that, also called a desiccant, is that you can use it for liquid products. Yeah, so you can add a desiccant or a drying agent to a liquid product, okay, or a solution, and you can remove any water in there. You obviously couldn't really do that with an oven because it would evaporate your product. So a drying agent will just remove excess water from your sample. A dehydrating agent, however, actually physically removes water molecules from the reactant molecules. It's actually a chemical reaction, so it changes. It makes a product. It's a chemical reaction, and it forms a new product because it's removing molecules of water from the compound, as opposed to just mopping up any excess water that may be there. So an example of that would be sulfuric acid. Okay, so sulfuric acid is a very strong dehydrating agent, and it will actually just remove water from a molecule. Now, you're hopefully going to see a demo of this, of a dehydrating agent, and I'm going to upload as well a video of it happening, just with a voiceover in case you either missed it or you want to look at it again. So that will just be in the same place as these videos, and you'll see that. So finally then, just going through the questions, nice and simple and nice and quick really. What was the general formula of an ester? What are the two ways of making an ester? What is the difference between a drying agent and a dehydrating agent? Can you give any examples? So, general formula then, RCOOR dash, okay, for an ester, because we've got our C bonded, double bonded to our oxygen, and then we've got this ether link between this carbon, this oxygen, and this R group. What are the two ways of making an ester? Well, you can either do it from an alcohol with a carboxylic acid, and you'd actually need a acid catalyst, such as concentrated sulfuric acid under reflux, and then phenol and acyl chloride. Okay, and basically that can be done at room temperature, but it needs to be done in the absence of water. Okay, for the second one. And finally, what is the difference between a drying agent and a dehydrating agent? With examples, so a drying agent, calcium chloride, mops up excess water, whereas a dehydrating agent, such as sulfuric acid, removes water molecules from the reactant molecule. It's an actual chemical reaction, and it gives us a new product. Okay, so hopefully that was clear. Nice, quick, easy one this time, and good luck in the lesson.